Okay,
Yeah.
you're on board. Cutting short on the presentation, I already was described well enough. Just to tell that, well, since the late 90s up to today's, I had the opportunity to play quite a little bit with this kind of tools, with meeting great people. When narrowing down to the specific topic of tonight, meaning rebar detection and structural details assessment, two techniques are involved. Now, I will begin just with a short overview of why you should have or use a GPR or Eddy Current. Recent years, my region is assessment of unknown existing structure, big infrastructure. Who knows what's inside there? Heat prevention, I don't care what the hell there is there, but I need to avoid it. Or quite consistent, was that building made as per specifications? Or as a part of the corrosion analysis. Now, this is a couple of years in Italy, but I can grant for all my experience that these four fields of applications find all the NDT user with different shares region by region, but we got a lot in common. Now, as a small warm-up, we're talking about rebar location by means of Eddy Current and GPR. So just a couple of words as short as I can on the measuring principle, just a reason to know what we're talking about and what we can do. Now, when I use a rebar locator, a traditional rebar locator, I will play with a magnetic field. I will generate a magnetic field inducing electrical currents on the surface of any conductive material, which in turn will generate an opposite field. That is the ultimate quantity that I measure. Pretty impossible to memorize that, but the key point is that a rebar locator Eddy Current gives us number. As good as the instrument is, it will depend on the accuracy, but we will always get an accurate cover measurement and a decent, or depending on the measuring scenario, rebar estimate. Well, when I get a GPR, I do have a device that basically sends an impulse into the a conical shape into the body it's examining, and it measures the distance like a sonar of the travel time. So I can imagine that if I travel across a metal rebar, I will measure a certain distance or time when I'm far from it. Then it will decrease up until a minimum. Then again, while I move out, I will measure longer arrival times. That is the reason of the appearance, of the typical appearance of a GPR profile. So we deal with images in here. So we already set the task that might ask us to be on site, but narrowing to the real applications, Eddy Current, by its measuring principle, only sees the rebars, first layer of rebars. GPR, on the contrary, can be considered a universal locator, as that it is sensitive to any metal or plastic or air void defect interface. Now, if I have to put down in 4 words, plus and the minus of both methodology, Eddy Current is really totally independent from concrete composition. That's something that a user always like. I don't have to set whatever parameters for the concrete being wet, new, old, dry. I will always get that shore depth measurement. GPR, on the contrary, is the versatility of that instrument is the real key power. You can see beyond an air layer, traveling on wheels, detached from the surface, and it has an exceptional capability of detecting specifically metallic elements, but not only. Now, if I flip the coin, if I flip the medal, I will see the other side, and eddy current I cannot really give any information on deep bodies, and of course, it's only limited to steel. For GPR, holds the same principle as all many NDT. Whatever I see best makes me blind behind, so I can see perfectly well metal elements. Then I will have a small penetration on behind heavily congested arrangements, and not as good or less effective when the concrete is conductive, so fresh or wet concrete. Okay, that just was a small warm-up. The progression I'm tending to propose today is increasing level of application and increasing level of expertise, trying to cover in big groups whatever can be done with a traditional locator and the GPR. So the first thing I can do today, just like I used to do about 25 years ago, rebar locators for on-site marks of first layer rebars. Well, then I might want to push my activity and my capability a little bit further, and I may want to address the mapping, the calculation, the assessment of quality of a concrete structure. And then, then I have to step up and move to GPR. We'll have a look at the key applications and features of GPR, and but then, wanting to do more, a glimpse of why choosing the right tool for the job. Different antennas, different systems can deliver, be optimal for different tasks. And if possible, I will just give a small teaser on what the range of advanced, what are called advanced GPR applications are. But let's start from the beginning. And on-site marks and spot measurement with rebar locators. Chalk in your hand, a rebar locator in the other, then you might want to drill, you might want to draw rebars just to avoid them. The typical first thought is about coring, but coring is not the only reason you want to avoid the rebars. We discover more and more that all NDT techniques, I mentioned 3 here, require the preliminary identification of the rebars in order to avoid the effect of the rebars on the measured quantity itself. So it's a necessary tool for everyone doing NDT. But apart from the chalk, we have handheld devices such as this Profoscope guys that as simple as the interface is, you can get always accurate cover reading and diameter estimate. Of course, it doesn't have wheel. You have to do your rebars one by one. It might come a time where you want to step up to more advanced task, and that's where you need a more productive device. Now, the profometer, belonging to the family of the cart-mounted rebar locators, can deliver easy mapping of broad areas, or just by keeping track of the geometry and accurate detail imaging of small elements. And of course, all the quantities must be ready for reporting. Now, just as a short